I think we're live now. Hi, everybody. Welcome you all. My name is Fatih Urda. I'm the chair of Turkey section. I'm a professor at Özyeğin University in Istanbul, Turkey. It's a great honor to be hosting today. I thank Region 8 for allowing us to be a host country. We have our speaker here, Mr. Tarcan Kiper. He is a very good friend of mine and an esteemed colleague. He has an industry career that spans 3 decades. Prior to that, he got his bachelor's degree from Bogazici University in Istanbul, Turkey, and he got his master's degree from Case Western Reserve University in Cleveland, Ohio, in the US. During those 30 years, he founded and managed 3 high-tech companies. The common theme in all of them was augmented reality and virtual reality. Now he's the CEO of Dors Venabili, a digital health startup, a stealth mode startup actually. And still the common theme is augmented reality, virtual reality. How come augmented reality, virtual reality is part of a digital health startup? That's a secret, at least partially. Maybe Tarcan will shed some light on it. And obviously his talk is on digital health. It's a very relevant subject in these days. Before I give the floor to Mr. Tarcan Kiper, I would like to let you know that if you have any questions, click ask a question. There's an ask a question link in the bottom. Click there and just type your questions. His talk will last about half hour, then we'll take the questions and we'll end in about an hour. So I give the floor to Mr. Tarcan Kiper.
Thank you very much, Professor Fatih Urda. I'm glad to be part of this IEEE event. I'm honored to speak here. Thank you very much for that. My speak today is about digital health. It's not so possible, to speak of every aspect of digital health because it's a vast subject, vast as an ocean. But I will try to give highlights, especially from the computer science, electronic engineering perspective. So, I'd like to start with some definitions and basics of digital health. It's an emerging category. Basically, when you say digital health, it refers to the convergence of digital tools with health and healthy living. And by the digital tools, I mean the digital tools coming, especially technology from defense, aerospace, and manufacturing industries. I will also give examples regarding that in the coming slides. Another definition could be the digital transformation technologies applied to the healthcare industry. Actually, since it covers a wide range of technologies, we can also consider digital health as an umbrella term, where basically it's the application of contemporary information and communication technologies and the leverage of these technologies actually to deliver, to proliferate the healthcare to the masses in the world. I can give you some examples regarding that, regarding the digital health, ICT applications and infrastructure. We can say, electronic medical records, remote sensing devices, telemedicine, definitely AI and machine learning. And for the past few years, people are talking about startups started to emerge regarding digital therapeutics, which involve computer-based interventions, computational biology, and especially new machine learning tools to parse and to try to create intelligent data from medical images and scans. But when we say digital health, there are main three targets for that. Improve overall health outcomes for patients, enhance the quality of care, and reduce health costs. There are very important key drivers because the sectors, the institutes, the stakeholders regarding digital health, everybody has a future vision on that. I can summarize them as follows. First of all, the focus would be on prevention and well-being before the treatment, actually. So people are working and talking on alarming and warning mechanisms and early diagnosis, tools to motivate engagement of consumers and patients. This is very, very important. I will talk on this in detail in a few minutes. Care delivery, not in typical hospitals or centers, but in homes, works, school, or local communities. The second biggest key driver, interoperable data and platforms. So we're talking about here the real-time information and insights for prevention, diagnosis, and treatment. Real-time and on-time, actually. Coming up with new devices and sensors so that we record health data widely available, especially secure data exchange, the protection of health data, the privacy of patients to avoid misuse of information, and also decision support tools like designing smart algorithms to support decision making, prescribe personalized treatment, and ensure compliance with therapy. Actually, what else? A key driver, and I think, and for most of the parties and stakeholders, this is the most important item regarding the future of digital health, which is the consumer engagement and empowerment. And it includes criteria like full visibility and control over personal health information, technological tools tailored to consumers' health goals and lifestyle, make access to someone's own health data a basic human right, and especially patient-centric caregiving methodologies and approaches. Especially from digital pharmaceutics, the paradigm which was talked about, which was started about a decade ago, the 4 Ps of digital medicine: to be predictive, to be personalized, to be preventive, and to be participatory. So when we talk about digital health, all the ecosystem of digital health work on these criteria to be delivered in the near future. I come more to the engineering perspectives now. For the past decade, lots of institutes, organizations, governments have been working on standards and regulations to draw the future of digital health. One of them is NHS. They are still working on a digital health technology standard. They've just published their draft this year. British Standards Institution and AAMI, Association for the Advancement of Medical Instrumentation. One is a UK body, one is a US body. They've been jointly working on machine learning AI in medical devices to bring a discipline to machine learning and AI usage in medical sector. International Telecommunications Union and World Health Organization, they've been also working on the artificial intelligence for health. I have, in the coming slides, I have one slide purposely for artificial intelligence. I will talk about details why. why everyone is trying to working on standards and methodologies, regulations regarding AI and machine learning. Another one is IEEE standard regarding personal health devices. Again, similarly, there are also standards regarding especially the electronic side, the electronic communication side of it. IEEE has been working on that. And I will also give a detail regarding the IEEE standard regarding wireless body area networks, which is a very, very key standard regarding the implementation of the digital health technologies. As I said before, digital health is a big umbrella and it consists of a big, big ecosystem, lots of technologies. I purposefully put the Industry 4.0 vision diagram there. Maybe some of them are aware. It's a big topic in the manufacturing industry, in aerospace, defense industries. When we look at the vision of digital health, actually, it is very similar to Industry 4.0, which is basically, I can say that implementing Industry 4.0 technologies also in the medical sector, health sector. So what are those? Information communication technology infrastructure, which include cloud computing, data analytics, cyber security, databases, etc., data exchanges, wearables, sensors, and trackers, mobile apps, e-health and m-health solutions, big data, AI and machine learning, VR, AR and simulation technologies, medical robotics, surgical robots, the topic telemedicine and telehealth, remote monitoring of patients, additive manufacturing and 3D printing. Now I'm going to talk about some selected technologies in a little bit more detail. Key technology arena, wearables, sensors, and trackers. The key criteria in digital health is to get real-time data. And the real-time data, it would be enabled by wearables, sensors, and trackers. They are good for real-time measurements, portable diagnostics, and they can give instantly available information. They also track very simply the daily habits, activities like number of steps, calories burnt, distance covered during daytime, sleep time and sleep quality. Most of you probably used or heard one mobile app which is for checking the sleep quality, or a simple smartwatch counting the steps of every day. I have lots of friends around me using these type of stuff. They are very quite popular. And the list goes more and more complicated. Also, there are sensors for blood pressure measurement, blood oxygen saturation measurement, and blood glucose levels. Also, another measurement class is body temperature, motion evaluation, electrocardiograms, heartbeat, heart rate variabilities to check the stress of the patient, effort and load, and the fatigue, daily fatigue. Also QRS events relating the heart rate and heart rate recoveries. What else? We can also speak about respiration rate, skin perspiration and capnography, electrodermal activities, galvanic skin response, and brain waves measurements. Why am I talking about these measurements? These measurements have been there for a long time, but until recently, most of them, you could only do the measurements, evaluations with big systems with very, very expensive hardware units, only in, specially equipped hospitals, the technology is getting smaller and speedier and cheaper, and we get access more and more, very simple home use electrocardiogram systems, definitely very simple blood measurement hardware, also heart rate or heart rate variability measurement smartwatches. So we have these measurements, we have these for digital health to establish the infrastructure of digital health. We need these data, and to measure these data, we are getting more and more access to reliable hardware at homes. That is the key. Sorry. Okay. We have the measurement side. How do we do these? There are lots of equipment, mini gadgets, mobile devices, smartwatches, and for the past couple of years, we see more and more startups and established companies manufacturing smart clothes with various sensors in them. Also chest straps, especially to measure heart rate monitoring, electronic headbands and electronic wristbands. Now, we started to see coming from the R&Ds of pharmaceuticals and universities under skin implants, bio patches, and we will see soon more and more digital tattoos. There are also haptic feedback devices coming to commercial use, and especially this year, we've seen some interesting measurement devices as wearable rings from big names like Samsung and Amazon and other big manufacturers. And of course, they all have with their own companion apps in mobile side. The key for these wearable sensor trackers to work, there are very important standards. And IEEE is the body, the responsible organization for the very two most important standards. One is the WBAN, Wireless Body Area Network Standard, and the other is Personal Health Device Standard. I especially want to stress for the interested parties trying to, come up with sensors, trackers, or biomedical equipment with the relevant software side, they have to check these standards. There are also compliance standards to establish the WBAN part. Bluetooth had come up with their own standard. It's called the Bluetooth Health Device Profile. It is described there, how health devices interact over Bluetooth among each other. And similarly, USB, they also have a personal healthcare device class. And also under IEEE 11073, Zigbee has a healthcare profile. So these are the important standards on the road to digital health. Now, big data, AI, and machine learning. I'm not going to talk about here, I'm not going to explain here, what is artificial intelligence, what is machine learning, etc. But I rather would like to stress, what is the importance of AI and machine learning and big data to the road to digital health. One key thing, there is a complex portfolio of healthcare data in the world, all over. Electronic medical records, all kinds of electronic medical records, from patient encounters, vital signs, lab results to prescriptions, but also lots of millions, billions of MRI and CT scans, echocardiograms, and angiograms. So there is a escalating volume of unstructured, heterogeneous medical data all over. And most of the, hospital systems, caregiving institutes, they don't know what to do with this vast ocean of data. So AI, they see AI as the rescuer, to orchestrate, store, interpret, filter this big amount of data coming from all kinds of facilities, devices, you name it. They include all kinds of diagnosis, treatment data. The main requirement is, to come up with such a data design methodology, filtering methodology, evaluation methodology, to come up with the suitable data for the personal use of the patient. What else? Second important thing is the risk seen in the AI part, in the AI technologies, and this is an issue, as I've told you in my previous slide, like ITU and World Health Organization and BSI have been working on, disciplining the AI and machine learning side. And the challenges that they try to, overcome is, the level of autonomy introduced by AI technologies. They can guess regarding the healthcare data. The ability of continuous learning systems to change their output over time in response to new data. Who's gonna say which one is right, which one is wrong? That is the key issue. And the third criteria is the ability to explain and understand how an output has been reached. So to answer these questions, they've been working on to come up with some standard methodologies, regulations, and infrastructure. Another important part of the digital health ecosystem: virtual reality, augmented reality, and simulation technologies. It's a hot topic all over the world for the past 5 to 10 years. There are two sides of it. I'd like to explain it like it. One side is for the medical staff, for healthcare employees, caregivers. The key thing is it starts with the training and education. More and more surgical simulators, minimally invasive simulators, surgical simulators, like for endoscopic, laparoscopic, orthopedic, and other operations in medical schools, faculties. More and more these type of simulators are being used for training and education. And especially for the past couple of years, we see lots of augmented reality-based applications, like when you put your mobile phone to an anatomy book, you can see the 3D organ models right away in front of you. These applications 10 years ago, they were science fiction, but now we see all around. What else? Training education side is okay. It's been there for nearly past 10 years, but newer stuff for medical stuff based on VR and AR simulation is the key thing is VR-based pre-surgery rehearsals. This is, patient-specific surgery. Before you do the real surgery, you rehearse it in VR virtual environment. And this requires, of course, the MR and CT scans from the patient and coming up with 3D models of the related parts, and then the rehearsal, the proof of concept work for the virtual surgical operation in the VR environment regarding that specific problem or surgery. What else? Again, it started being used, recently. The telepresence part. It's like the real-time streaming of surgical operations with VR cameras. from the real operation room for worldwide distribution. Like, some surgeon, expert surgeon is doing a surgery. He has 2 stereo VR cameras on top of his head, and some medical students somewhere in the world, they can real time see the operation as if they see with their own eyes. And also, especially for health technicians and nurses, that are also, we see more and more serious games type of, a little bit, training, education, and learning, but with a little bit entertainment. We see more and more serious games. Second side for VR, AR, and simulation application is for patients. We see more and more VR enhanced cognitive behavioral therapies. We see more treatments for anxiety, phobias like, claustrophobia, agoraphobia, height phobias, flying with the plane phobia. We see more and more applications, very successful applications and implementations of these type of, behavioral therapies using virtual reality technology and environments. And also, we see more and more treatments for pain distraction, post-traumatic stress disorder, PTSD, stress management and prevention. And as far as I know, recently FDA, in its history, for the first time, certified a PTSD VR-based game application. Yeah, so I mean, the world is going to interesting road. We also have virtual rehabilitation exercises. When you have a problem with your knee or leg, or when you had a surgery, limb surgery, let's say, the rehabilitation, they don't know, you just sit there and do the rehabilitation, but they do in a VR environment, so it becomes more entertaining and more motivating for the patient. All right. Oh, another interesting technology in the ecosystem, additive manufacturing, 3D printing. It started with printing of anatomical models for training and surgical planning and simulation. It started with actually the training side of it. And we see now more and more patient-specific implants and models based on CT and MRI data. So that, they do the really real-time, on-time 3D printing of the replacement part, the limb, and the required prosthetics, custom-made prosthetics. And naturally, we see more and more now coming out of the labs, R&D labs, universities, growing organs and bioprinting of tissues. I know they were very successful last year to bioprint a liver tissue and the cartilage for the ear. So we will see more and more on these technologies. This additive manufacturing side consists of lots of science in it, from material science to biomedical engineering, you name it. So, but this is a very, very key, interesting technology of the ecosystem. I'd like to give you an example. This is not digital health, but it's a very, very solid example for digital health. Not everyone is aware, but actually sports and fitness technology is a big success for digital transformation. That's why currently in the world, who whoever would like to take part in digital health, do some business, some projects, they are getting lots of examples and success stories from sports and fitness technology side, because sports and fitness technology side has been using real-time performance tracking, all kinds of measurements with all kinds of sensors are available since years, and it's very successful. They also came up once with their own communication standard. It's called ANT Plus. It started as a proprietary standard, but now it's an open access. In some health-oriented, medical-oriented performance measurements or any type of sensing and tracking, also some companies started using ANT technology. When I said, AR, VR, and simulation would be a very important part of digital health, this is already a part of sports and fitness technology since years. So there are a lot to learn from that market. Before I finish, I'd like to speak about some future efforts. For me, two important subjects on the way to digital health. One is called digital twin. Digital twin, as a subject, is coming from manufacturing industry, especially coming from aerospace. But regarding digital health, it means achieving a personal digital twin for every citizen. What does it mean? It is a dynamic virtual model or digital replica of the person, of the patient. So there is the entity, the real entity, the patient, the person, and digital counterpart, a connection between them. This means that the patient's all kinds of vital statistics and data are measured and stored in real time, and this data is implemented and used, applied to ML and AI and whatever deep learning in real time. So this is the future, one of the main, very important future visions. There is also a project in Europe covering about 32 countries and more than 200 institutions. It's called DigiTwin project, a European Union project. And lots of companies and institutes and universities have been working on that. You can check that through their website. Another key technology is physiological simulation. It is a totally mathematical mimicking simulation of the human physiology, so that you can model conditions, symptoms, and drug effects. The main idea is here to come up with such a high fidelity human physiology simulation, so that there would be no real life trials, human trials of drugs, but rather than again in the digital environment through software simulations. And there's also a big effort started years ago in USA. It's called HumMod. You can also be part of it when you would like to try a physiological simulation. So I thank you very much for listening to me. I tried to give you some engineering perspective, especially from the engineering side of digital health, what kind of technologies would enable this vision in the near future. Thank you again.
Thank you, Tarcan. Great presentation, as always. Can you hear me?
Yes.
Okay. Now, are you ready to take the questions? We have quite a few questions.
Yes.
You can also possibly see, do you have an Ask a Question link in the bottom of your screen?
Yeah.
But I will still read them to you. Most of the questions come from Rida Kayri, if I'm pronouncing the last name correctly. Let's start with Rida's question. As you see the world of today, stands helpless in front of a pandemic, do you expect with digital health more precautions in future in order to stop epidemic at its first origin?
Absolutely, I'm very positive on that, because let's not forget this. Actually, I want to stress again, the key thing with digital health is actually that's why I gave the sports and fitness example. The success in sports and fitness example was the involvement of people. You know, people themselves, the runners, the marathoners, the bikers, they wanted to be involved. They wanted to use those technologies. Same in digital health. Companies are trying to accomplish that. They say to people, hey, we are responsible for our own health. That means that, we have to be precautious, we have to be preventive. That is the main key humanistic side of digital health. That's why, when in the future, in 5-10 years now, when this vision would already be established, today's pandemic would not be so bad,
After all. Okay, thank you. Another question from Rita. Do you expect from doctors to encourage telemedicine? So I'm sensing that Rita is expecting some resistance from doctors.
Yes.
Against telemedicine, digital health in general, because I think it's going to replace some capabilities of doctors.
No, that is not the main reason. It's not going to replace. Don't forget that in health industry today, there is lack of physicians and nurses around 5-6 million. It's a huge number. I mean, there are lots of things to do for doctors anyway, but there aren't enough of them.
But what's the impact of it on a particular doctor as an individual?
Sorry?
What's the impact of digital health, telemedicine in general on a single individual doctor?
Yeah,
loss of revenue, loss of salary, partly?
Digital health would enable the doctor, the physician, do his job more, better, much better. On the other hand, it would have much more realistic data. It would have much more feedback coming from ML and AI based on those patient-specific measurements and recordings.
How about primary care physicians, practitioners, or family medicine?
Yeah.
Like basic internal medicine doctors.
For sure.
For specialists, it will let them do their job better.
For sure. Like in every industry, as we've seen in automotive industry, robots replaced lots of, conveyor belt workers. But conveyor belt workers, some of them transferred to technicians, to operators operating these robots. Similar is expected in digital health sector. It has to transform. I want to give another major answer to that. The sector is speaking on the problem with health sector is the medicine. They are not aware of information and communication technologies. There are lots of brand new papers and conference calls regarding on that putting ICT technologies into the curricula of healthcare. So this is also key. Most of them, physician, doctor, or nurse, or an expert caregiver, they are, so to speak, generally in the world, they say, computer illiterate. So they need to overcome this also.
I see. Thank you. So let's continue with the third question, again from Rita. Are there any regulations to protect health data of patients when processed with digital health?
Yes, I don't want to say there are regulations, but definitely there are, private data regulations, but they are working on that. Like FDA is working on that, NIH is working on that, governments, institutes are working on that. I didn't want to talk about this in my presentation because they are more, it's the, politics side, legal side, but yes, there are. That is the key issue actually in other part of digital health.
Do the current laws of sharing digital information about people, do they automatically cover health data?
It's problematic.
There's a vacuum there?
Yeah, it's problematic. It depends. Sometimes even the patient cannot access its own data, his or her own data.
Okay. Next question is from Tunçer Baykaş, our vice chair of Turkey section. What do you think about the use of social media data to track pandemics?
Good question. I'm an old generation. I'm not that much of a guy of social media, but yeah, why not? I mean, yeah.
So I think this is a there are two aspects of this question, I guess, two dimensions of it.
Like early warning system.
Right, but then how legal is it? Maybe.
I don't know.
Okay.
When it comes to sharing information and data, I mean, this is not just related to digital health, but for every kind of data, it's a big problem in the world. Right. There are also misinformation, fake data,
Right.
It's critical.
So the next question is from Vincent. Do we have COVID-19 data set with labeled data that may help in training machine learning models?
I'm not aware of that.
Okay. Next question is from Sudhir Rutre. What are the prospects of NB IoT? Is it narrowband IoT in healthcare? NB IoT in healthcare.
I'm not an expert on that, but institutes like IEEE, device manufacturers, they've been also working on that, to come up with one standard actually. This is also valid for data exchange. So I've never seen a standardized version of that yet.
Okay. Another question from Rita. Is digital health included in medical university courses? And Sudhir commented on it. Yes, in some universities, mainly it's taught under IoT for healthcare. Do you agree? Yes. Do you have anything to add?
I can add this. This is a major issue, as I've said before. It's a hot topic. Embedding or involving also, computer science-based lectures in medical training.
Okay.
There is a big gap between, the typical medicine study and the ICT side. They need to make a bridge. That's one of the key criteria of reaching digital health.
Okay, thank you. The last question so far. Given the failure of IBM Watson, what hope is there for AI to be used successfully for diagnostics? Who would be held responsible for a misdiagnosis in case of AI use?
Very tough question. We can discuss it weeks. Basically, to overcome all kinds of potential problems. As I said, standards organizations are working on that, have been working on that to bring a discipline. Unless, as Elon Musk said, with AI we can summon the devil. That's true. I can't answer that because there is not an answer here.
So it's like autopilot cars, right?
Yes.
So who killed the pedestrian?
Yes.
Yeah, it's a tough question.
No one has the answer yet. That is the issue. That's why governments have been working to come up with methods and standards.
I also personally have a question relating to AI. Speaking of AI, I'm really not, I'm quite skeptical of AI. There are many people who are not skeptical, who are proponents of it, enough people of that type, but unfortunately I'm very skeptical because AI doesn't have common sense.
Yeah.
Right? Humans have common sense. So, and a lot of times for people to get something meaningful out of AI, you have to clean the data.
Yeah.
But you don't always know when the data is clean or not. But a human being, based on the results, can raise a flag, can say there's something observed here, right?
Yeah.
Like even when a person, he or herself, makes a decision, we can override our own decision. We can go, what are we doing?
Yeah.
But AI is not like that. AI is basically just fitting data to some model, right?
Yeah.
So, like, how are we going to bridge this gap? But then on the other hand, some problems, it's very good at those problems.
Yeah. But, Fatih, first of all, who's going to teach the AI? Right. Who's going to teach AI with what kind of data? And who's going to decide on which data to use or not?
Right.
There are no answers yet.
Right. At least there are questions.
Currently, in industry, in companies and universities, etc., people are trying this.
Right. Okay. One more question arrived from Ömer Gül from our Turkey section's Young Professionals Chair. What are your solutions for security and privacy problems in healthcare? Privacy is important for patients. I'm pretty sure Ömer means not the open question of what should be accessible, what should not be accessible. I think he's asking in the context of after deciding what's accessible, what's not accessible, maybe how do we prevent the hackers from accessing it and so on and so on.
Good question. I'm not an expert in cybersecurity, but I know from the digital health world, there are also lots of topics they talk about. One key solution people talk and propose. We've been also trying to implement it. Distributed system, taking advantage of blockchain.
Right.
On the other hand, the other alternatives are, very, very typical alternatives that you use in defense, aerospace, intelligence agencies. They are not different from that.
Right. And whose blockchain is it? Is it the government's blockchain, or is it really a blockchain as it was meant to be, public's, common people's blockchain, right?
Yeah. I don't have
whose blockchain is it? Okay. So regarding digital twin, is it like what we're trying to do? Is it like a burn-in test that we do in electronics? Let the digital twin of the person get burned in, meaning you're 30 years old, but then the digital twin, the clock is progressing more quickly, running faster, living faster. So the digital twin is 60 years old. So you can tell what kind of problems this 30-year-old person will have when he's 60 years old. Is it the idea?
This is one of the application ideas. The main idea is, to store your digital replica somewhere Why? Because, as you said, I can do simulations on that, tests on that, without disturbing you. There is not a technology like this yet. They are trying to come to this technology, because this technology they've been trying to use in aerospace, defense, and automotive for the past, maybe 5-10 years. Now they are trying to implement the similar ideas for the human health, but it's a vision. So you have the system will have, or you will have your own real-time, digital mirror somewhere. You can do some tests and treatments and trials on your digital twin. That is the main idea. Okay.
I see. Thank you so much.
You're welcome.
Thank you also for great answers. So people, in case you joined later, after the talk started, this session was hosted by IEEE Turkey section, and I'm the chair of IEEE Turkey section, Fatih Urda. We'll be hosting another talk at, I believe, 9 o'clock Turkish time, 8 o'clock Central European time. We hope to see you there. It's going to be on LoRaWAN, a communications technology, and a like new upcoming communication technology, networking technology. So, Tarcan, unless you have something to add, or unless the audience has something to add, I would like to end this session.
Thank you very much for listening to me, for your patience. I appreciate that. Thanks a lot.
Thank you for being with us, and thank you for the great talk. Simay, can you come in? And I don't know how to end the session.
Sure. Yes, thank you very much for being here, and thank you everyone for watching. We're ending this session, and next session between actually the session we're gonna host is Turkey section.
Simay, your voice is fading away.
All right. Can you hear me better?
Yes, much better.
Okay, perfect. So, and the next session is the award ceremony. So, which will start exactly at 5:15 Central European time. So you can just go and watch the other sessions, and we are looking forward to meeting you again at 8 p.m. Central European time. Thank you very much.
So, Tarcan, last but not least, we're receiving many thanks from many countries. Lebanon, Spain, all over the world. Thank you.
It was a wonderful session. Thank you so much for speaking at the session.
For being here. Let me type my message.
Okay. Thank you, everyone. See you later. Bye.